In the previous video, we were talking about the universal sentence encoder and how you could go about generating embeddings for sentences and text as opposed to just words. And there are many properties that we like, but we should start talking about one big weakness. And this weakness doesn't just hold for the universal sentence encoder, it pretty much holds for most embeddings. So on a very high overview, we start out with text, and then this is usually turned into a representation of tokens. A lot of these are 0, but there's a couple of 1s whenever we actually hit a token. Once we've got our sparse array of tokens, we usually pass that through many layers for making the embedding. Maybe we use an attention mechanism. We probably do some pooling here and there. But we've got many layers, so to say. And then at the end, we've got our final embedding output. And the way that you might go about training this is by taking lots of data and by then training it on lots of tasks. And the idea is that by adding more and more tasks, that you might be able to force this embedding to indeed be very general. So maybe the first task is that you train on Amazon reviews, where you want to predict the sentiment. And maybe you've got a data set with questions and answers, and you want to get a signal out of the similarity. And again, you can have many of these general tasks. Then this approach, we could argue, is pretty good for getting embeddings that are general. There's a potential that they summarize the language in such a way that you can use these features in your modeling pipeline in order to get a performance boost. And there's merits to this idea, but maybe now would be a good time to take a step back. And maybe we should look at this not so much from the quantitative angle, but maybe more the qualitative one. Because there's a benefit to having embeddings that are indeed general, but there's also a really big downside. So let's take a step back and let's consider the more qualitative aspects and ignore the qualitative ones just for a moment. Let's say that we are building a digital assistant in the healthcare domain. If we think about the text that we can expect to see, what are some themes? Well, first of all, I think we'll see some really specific jargon. I can also imagine that the input device, possibly that's going to be a mobile phone, that's going to have all sorts of consequences, but a main one will be spelling. I can also imagine, depending on the kind of healthcare assistant we'll make, that a lot of the text that we receive will be written while the user's in a state of urgency. That is going to have an effect on the type of conversational style. But I think it's also fair to say that potentially we get a lot of commanding tones in our text as well. Even if we do the right thing, I don't think we'll be getting a lot of please and thank you, and users will probably say things like, "Oh, do this for me." That's text in the commanding tense, so to say. And note that this is also often referred to as the imperative tense or the imperative mood. Anyway, when you start writing down these qualitative measures, you quickly get a feeling that the problem that you might be solving, odds are that is relatively specific. And these pre-trained embeddings, be they for sentences or for words, they are usually trained to be not specific, but general. And to emphasize this point, let's take two commonly used datasets that are used very often when training embeddings. We have, of course, Wikipedia. And if I think about the text that you'll find there, well, it's usually really formal. And it's usually written in the past tense. And that is because the content that we have there is fairly academic. It doesn't resemble a conversation between two people. Instead, it's literally more like an encyclopedia. Another consequence of this is that we can expect excellent spelling. Another very commonly used dataset is the Amazon reviews dataset. This dataset is substantially different from Wikipedia. It certainly is less formal, but we still have some level of bias in our text. The reason why people post reviews on Amazon might be because they either really, really love a product or really, really hate it. So also here you can wonder, well, there might be some lessons learned from the Amazon reviews dataset, and there might be some lessons learned from the Wikipedia dataset that might be useful to our specific use case, but we should remain critical and perhaps ask ourselves the question, do the lessons learned while training general embeddings, do they really apply to our specific use case? And it's good to take this question serious. When we're trying to design a healthcare assistant, then we should be mindful that we're really solving a very specific instance of a very specific problem. The fact that these general embeddings perform well on a couple of benchmarks is of course interesting, but I hope that this particular instance here convinces you that maybe we shouldn't be too impressed with these general benchmarks. There's a compelling argument here that text from Wikipedia is simply too different from the text that we are interested in. When you compare these qualitative properties, I hope it's clear that this is something that we should keep in the back of our mind. We might just be adding noise, bias, or irrelevant information to our system if we're not careful. We shouldn't assume an improvement whenever we add pre-trained embeddings. It will really depend on the specific problem that we're trying to solve, as well as the datasets that these embeddings were trained on beforehand. So if we now take a step back to this diagram, we can maybe wonder, well, can we maybe redraw this diagram for our specific use case? Well, in our specific use case, we might have text that again is going to become tokenized. And after that, we can make it go through many layers of attention and pooling once more. But instead of now making a very general embedding by hooking it up to all sorts of tasks, we can maybe say, well, let's just constrain ourselves to the only tasks that matter to our specific use case. And as far as natural language understanding goes, there's typically two main tasks that I care about. And that's intent classification and entity detection. The idea here is that my specific system should only be judged on the intents and entities that matter for my specific use case. But if I were then to think, well, what sort of embedding comes out at the end over here, then we might need to stop and maybe observe something else. Because there's already a well-known name for a system that does exactly this. And that name is Diet. It's the standard model that we currently use inside of Rasa. Every time that you train a Diet model, it will be optimizing for detecting both intents and entities. And note that Diet internally uses transformer layers, attention mechanisms, mini layers, and pooling to get to this final representation that is useful for these tasks. It's just that usually this final part of the entire architecture is not exposed as an embedding because we usually don't care about the embedding. Instead, we only care about the performance on these two tasks. Note that this is inherently different than in the use case that we have above. Here we attach many different tasks because the final output of this system is this set of embeddings. But if we really only care about these intents and entities, then suddenly this representation at the end just doesn't become that interesting anymore. It's not a tool that will help us in our task. That said, what we can do is we can take these pre-trained embeddings and use them as input in our Diet architecture. This is one of the main benefits of Diet, by the way. You can add embeddings if you like. It's highly customizable. But the fact that we're able to add these embeddings doesn't necessarily mean that we should or that it's always a great idea. Because let's think about it one more time. What information are we actually putting into our model here? Well, potentially it's the lessons learned from Wikipedia and Amazon reviews. So what happens when this information goes in? Well, the hope is that our model is able to distinguish the relevant parts from the less relevant parts. It will try to not overfit too much on the embeddings that we have over here, but the only way that it's able to actually do that is to listen to the gradient signals coming from our labels. Those are going to update all of our layers and attention mechanisms to hopefully make sure that we don't overfit on something general and that we can instead focus in on something that's specific. But in order to do that, I do hope one thing is clear. These pre-trained word embeddings, they're nice and all, but their importance pales in comparison to what we've got here in our labels. If we don't have a whole lot of labels to start out with, then we are at a huge risk to maybe start overfitting on these general lessons learned from the general use case. In this playlist and in this channel, I've been spending a lot of time explaining how many of these different embeddings work, and I also think that as a practitioner, This is fair in the sense that it's good to understand what's happening under the hood. But I don't want to suggest that it's these pre-trained embeddings that are the reason why you might achieve natural language understanding for a use case. It's the labels. The labels will be the most important thing in your whole natural language understanding pipeline. So feel free to keep in mind that, sure, we can put embeddings into our system here that can be beneficial, but before you go and try out all of these different pre-trained embeddings on your pipeline, maybe consider one thing. Let's say that you have your dataset and you're going to do the big effort. You're going to take all of these pre-trained embeddings from fast text and from Hugging Face and from all sorts of places to figure out which one fits best to your use case. Well, then you should consider that you can do that, but you can also take all of that effort and stick that into getting more relevant data instead. And if you were to wonder, well, which of these two things might be the most effective, then 9 times out of 10, especially if you're just starting out, you shouldn't have to worry too much about embeddings. It's these labels that you have to consider, because it's those labels that will allow you to go from a general embedding to a specific use case.